All right, so what are we doing here?
So we'll actually go through a new app called TODOOSE and see what we can, like we'll go through building it from scratch. We'll go through designing specifications. We'll have a look at what it should actually look like before we do wireframing and diagramming. We'll go through the different specifications we need for the API. We'll write tests for it. We'll use version control for it. We'll actually set up like a GitHub repository so that people can know how this is done and not be lost in the wild wilderness when they're actually doing their first project.
Yeah, my idea with this video series is that people see the finished app in the lectures because we don't have the time to create everything from scratch.
Yeah.
But many people are lost in this process, and even people that know what's going on, they would benefit from seeing how the sausages are made.
Yeah.
So that's the purpose of this series. We have all the time we want. We're not going to cut and you know how these YouTube videos you are doing something and then jump cut, it's done? Yeah, nothing like that. We want to show the full process of creating an app from scratch. We just have an idea and we don't even know all the tools we are going to use.
Use for this, yes.
So the idea is to just create this from scratch and do it together, and we'll go through the whole process from coming up with the app idea to writing the tests and designing it and then creating the real app and
deploying it on, let's say Heroku or something like that.
Yes. Yeah. So the idea is to show the whole process.
With all the errors.
With all the errors, yes. I think that
big point.
We learn, and people that are watching are also going to learn from the mistakes that we make in this process. Okay, so as you said, the app is called TODOOSE because it's a to-do list for ooze.
Yeah. We couldn't come up with
I came up with this name walking to the lab this morning, and I thought it was brilliant. And of course, this is just reminders in macOS. It's just a to-do app that already exists. But it's a good example of what our app is going to do.
Yeah.
And what you can see here is just a list of items.
Empty items right now.
Empty items right now. But one thing we can do in this app is to read to-do items.
Yeah.
We can see them. Also, we can create new ones. We have this button right here to create new to-do items.
Yes.
Also, we can always come to an existing to-do item.
Create another
if you make a typo
one,
on the to-do item, you can come here and edit a to-do item.
Yeah.
And if a to-do item is done, then you can mark it as done. And it goes away.
Yeah.
That's the whole app. It's a very simple app.
Yeah. Just enough to actually like get us through the entire process of figuring out the idea, figuring out specifications, wireframing it, tests, and then finally deployment.
Yeah. It's a very simple app in scope, but we are going to go through the process of creating an app that establishes a pattern for growing the app. So if we were to make this fancier with more features, we would follow the same process to grow the app in all different ways, and it would
figure out new features and write new API specifications and write new tests and deploy it in a way that it's integrated with the previous versions.
Yeah.
It's literally you take this and you extend it.
Yeah, and that's a pattern that you can follow for your group projects. It's something that you can use in industry,
real life,
in open source. It really transfers very well to all sorts of places. Okay, so how do we even start with this? Well, currently it's a work in progress, but this is going to be the website for the course. And we have a curated set of tools that we call the toolbox. And we have tools here for everything you're going to need this semester. Starting with the IDE that you're going to use to edit code, to the platform you can use to deploy, everything in between, it's all in here. And you have to go through this list and install all the things in here, but I have already done that. It's somewhat boring, but also necessary, so I did it off camera. And
please upgrade everything. Please.
As the head CA, you had to install Java many times for students
I don't want to do it 100 times over. Please do it.
Yeah. So your first task, if you want to follow along, is to install all these tools, and you're going to need to do that for the homework and for your group projects as well. So it's a good idea to just go through the list. For each item, we say how to install or update. So you just go through the list and install and update everything.
Yeah.
And yeah, so with that, we can start to work. I think that the first thing we need to do is to do some wireframing and diagramming.
Yeah.
And for that, we need paper and pencil. But I thought, and maybe you agree with this or maybe you don't, I thought that we could skip this part for this app because it's so simple and because we have a sample
we know
to
what
go
exactly
with.
to do. Yeah.
So if we were to build a more fancy project here, we would do the wireframing and the diagramming.
Yeah.
The wireframe would look like this pretty much because this is so simple.
Exactly what you need here.
Yeah. And as far as the diagrams go, the class diagrams and everything, I envision that there will only be one class for a to-do item.
That's it.
It's so simple that we are going to forego this part of the process.
But this is integral. Like wireframing and diagramming is crucial when you're actually designing a project. I know we're skipping through it, but you should really take time out and figure out what your classes should be, what the relation should be, and what attributes each of these classes will have. Yeah. That is what will decide how your API specifications work and how your server and your front end actually interact.
Yeah, and during the course of the semester, we are going to do this for other apps that are more interesting in scope.
Yep.
But yeah, so with that out of the way, we can move on to setting up the project with all the tools and everything we need. So to begin with, I think that the best way to start is just create a project
with
in IntelliJ. Yeah. So I'm going to open IntelliJ and create a new project. And IntelliJ takes a while to open. So how are things, Yash?
Good. Been a long day, apparently.
Yeah, by the way, use Ultimate, okay?
Yeah.
Don't use the community version. We are going to need some features in Ultimate.
And you can get educational licenses for this.
Oh yeah.
So you don't really have a problem having it for like a year or something.
It is a paid product,
yeah,
but you'll get it for free because you're a student.
Yes.
So create new project. And the first thing is we have many options to choose here.
Yes.
There are many different kinds of projects, but we want one kind in particular. I mean, we are using this as a build tool, Gradle, and you can see it's here in the list of, right here, the build system is Gradle. And the build system is going to do many things like invoking the compiler and managing the libraries and dependencies.
Yeah.
So when we start the project, we can say that we want a Gradle project.
Yeah.
And it appears that I need to do some setup that I was supposed to do off camera, but I updated Java and I didn't update this part.
Yeah.
We are using the latest version of Java because we need the latest features.
Yes. And again, please upgrade.
If you are like me,
don't make it do it.
Yeah, if you are like me and you had Java before this course, because I was using Java before I started teaching this. So I had Java 11, or even some of you may have like Java 8. I don't know.
7. I saw 7 last year. That's why.
That's terrible. That's like 10 years ago. So update to Java 12, go to the Oracle page that we link on the website, and update to 12. And in IntelliJ, you say that you want to use Java 12, okay?
And that's critical again, because 12 will have features that 11 and 10 don't have.
Yeah, and in IntelliJ, you're going to have to say that you're using 12 like 5 different times. Yeah. This is the first one. Okay, so we have now to say the name of the project.
Yeah.
And group ID and artifact ID. Those are really like the name of the project.
Yeah.
So I'm going to call it TODOOSE.
Deliverable, I don't know, yeah. They're basically delivery identifiers. I think, I can't remember build identifiers in iOS, yes. So what happens is when you're actually submitting an app to the App Store, you need a unique build identifier and then a version suffix after that. And that build identifier is how Apple recognizes your app on the entire App Store. That is linked
iOS? What are you talking about? We're building a Java project here, man.
I have just build identifiers, that's all.
Yeah, that's just a name for the project. And I suppose that this name is not taken.
No.
It's stupid enough that no one has thought of this name before. So TODOOSE.
Yes.
Version 1.0.
Yes.
You could have the snapshot here, like this.
Yeah, I don't get that, to be honest. Yeah.
Never mind, 1.0.
Standard versioning is good.
Now next, I don't know what any of these are. As long as I'm using Java 12,
Well, it should be fine.
It should be fine.
Yes.
And I'm going to create this in this folder, fine, and the project name is this one, finish. And now IntelliJ is going to think for a few more minutes and come up with a project. Okay, so if this is the first time you're opening IntelliJ, it's overwhelming, I get it. But there are just a few things that you need to understand from this interface. The first is the project view. It shows you all the files in the project.
Yes.
Currently, there are a few files that IntelliJ put there when it created the project. But we are going to create more files here. Another thing that you need to care about right now is the version control panel, which I don't see.
Yeah, just put that up.
I
think there's a no. VCS has a pop-up integration thing. Is that it?
No, that's not what I was looking for. In any case, you can see that IntelliJ is doing a bunch of things here. Just because a project exists, it does a bunch of things. Like it is trying to compile the project, running the tasks here. There are no files to compile, but it's just setting up everything for the project.
Yes.
And just by doing that, you can see that there are more files here now.
Yeah.
And okay, coming back to version control. I think that there is some panel here for version control. New enable version control integration. Probably what we need. Yeah. So if you look at the toolbox for version control, we are using Git. Version control system is Git. So there may be other options here, but we want to use Git. Okay. And now we have this view that I was thinking about. We have this view for version control. And yeah, so it's a good time to briefly explain what version control is, in case you have never heard of it. It's just a way to save the states of the project as it evolves.
Snapshots, basically.
Yeah.
You're taking screenshots of your screen, like through different parts of time, that's all.
The way I like to think about it is, I like games, and I like to think of it as save states.
Yes.
So you can always return to a save state and see what you were doing previously.
Yeah.
So if it's like your project is a game and you're saving along the way.
Yeah.
And currently, we don't have any saves. We just started the project. So everything in the project is new. So all these files here were created by IntelliJ and Gradle automatically, just because it's a Java project. These files are already there. And with that, we can create our first save.
Yeah, first checkpoint for this.
The first checkpoint, exactly, yeah. So we can come here to commit. And that's the terminology in Git for creating a save state. So we come here to commit, and we have to select the files that we want to commit. In this case, all of them. I don't even know what they are exactly. I just want all of them. So I'm going to call this the initial commit. This is a message that you write for yourself.
Yeah.
It's like, I fixed a bug.
Or if someone you're working with.
It's just a message to explain what's going on. So if you can say like, I killed a dragon before the save, or I fixed a bug. Or in this case, it's just the initial commit. The project
commit messages would have been a lot more, it would be really helpful in saving game states. God of War, I went back like 50 times, never could figure out how to get to the right one. So
yeah, I play old games, so I play them in an emulator, and it gives me an option to write something.
Okay.
Anyway, so with that, we can commit. And that's our first save state.
Yeah.
And now you can see that the list of changes, the change list, is empty. Not because there aren't any files in the project, there are, but because none of the files are changed since the last save, since the last commit.
And it's generally a good idea to just create an initial commit or a save state as soon as you've created the files.
Yes.
So that way you have like the base foundation of your project, and then you can figure out, okay, let's screw up some stuff. That's how projects work.
Yeah, and if you're like me, when I'm playing games, I'm playing them on emulator, so I can save anytime. I save all the time. I do one jump of a platform, I save again. And it's a good practice to do that when you're developing the project because you avoid losing files. You can always return to a previous state if you decide that something was bad. So yeah, now that we have this on our machine, we want to be able to collaborate, right? We are working together here with two computers. So we want to be able to collaborate. And to collaborate with this kind of version control system, we have another tool in the toolbox that is GitHub for project management. So what we have to do is go to GitHub, and I already have an account, but if you don't, you create one.
Yes.
And we are going to go to the TODOOSE organization and create a new repository for TODOOSE. For your group projects, you don't have to create this repository because your head CA is going to create the repositories for you.
Yeah, that's my job.
But if you are going to do some other project on your own, or if you just want to play with things, then go ahead and create your repository like this. And let's make it public, shall we?
Yeah. I don't think there's any use making this private.
Yeah, if you make this public, then anyone in the world can see it. But we want you to be able to see it, so we are going to make it public. And now this repository here is empty. This is similar to the repository we had in IntelliJ on our machines, but this one is in GitHub. So it's like you have a different place to save your game. And you have all your saves on your computer, you have this other place. What we want to do now is to transfer the saves
from your computer to the
computer to GitHub.
Somewhere else. Basically torrents where other people can download your save states and play on from there. Exactly.
So GitHub is giving me this URL right here that I can copy. And I can come here to IntelliJ, in version control system, Git, and remotes. Because from the perspective of my computer, GitHub is a remote. So I can come here and add a remote. I have to give it a name, and by default, usually people give the origin as the name of the canonical source of the repository, and the URL I copied from GitHub. Okay. So it's now checking the URL and doing its thing. Everything in IntelliJ seems to take like 5 seconds. Okay.
There's enough latency there.
Now that we have this, we can push. So we can come here to Git and push
option.
So we have all the save states on our machine.
Now let's put them on GitHub.
Let's put them on GitHub that we are calling origin here. So we just push, and what we are pushing here is just the initial commit, the one we just created. We just push, and now it's doing its thing, and it was successful. So if we come back to GitHub and refresh,
you'll have files here now.
You see the files here and the commit, and my pretty little face saying that I committed at this time, and there is a unique identifier for the commit and everything.
So having that person or a signature associated to a commit actually helps in accountability. If you screw up, it's on you. Someone will be able to track it. And if you do good work, again, it's on you. You get the praise for it. So I think that's a very, it's a good thing to have.
All right. Are we missing something for the setup? Yes.
We still have a lot to do.
We still have a lot to do. But I think that we have something to start with. I mean, we are going to need to do more setup when we start using a continuous integration server and when we try to deploy. But I don't even know what a continuous integration server is at this point.
Way too far. Way too far.
So I think this may be a good point to stop this first lesson, this first session. It's just a very simple setup to get things started. On the next one, I think that we can start thinking about our API.
That's what I was thinking. Like creating something like specifications and figuring out how to use Postman and then actually working with it.
In fact, there is a very important thing that we forgot to explain. The architecture of this application. It is a web app. It runs in the browser. Here we have a desktop app, okay?
So that will be a major difference actually. Web apps, they will run anywhere. You just type in a URL as long as you're on the internet, works.
So this is a desktop app. We're going to build a web app. So you're going to go to some URL like TODOOSE.com, I don't know.
I don't know what that site is right now.
It's going to be somewhere, and you're going to see that app running. So we need some way for our server to communicate with our browser.
Yes, so that it actually gets there. So that whatever is on the internet is communicating with our server, and the request can be passed on from our whatever backend we built to the front end that is actually on the internet.
Yes, and we need some way for these two different components to communicate.
Yeah.
And that's going to be the API, which we are going to do next.
Yes.
All right.